So last week when we were talking about derivatives, you learned about the power rule, and you learned about the rule for adding and subtracting. We did not talk about multiplying and dividing because those are kind of some different kinds of animals. So let's start out. The very top says rewrite the function and then find the derivative. So when we rewrite it, we're just going to basically FOIL. First outside, inside, last. So we have 15x cubed for the first terms. The outer terms get you 12x squared. The inner terms are negative 10x, and the last terms are minus 8. So we FOIL. Then we find the derivative, and now we have the quick way. We can just use the power rule. So we say 3 times 15 is 45. What do I do with the x cubed? It's x squared, right? You take off one exponent. Plus 2 times 12 is 24, and that's x to the first, minus 10, and our constant is nothing. And that's how we do derivatives. Here's a rule that you need to memorize for multiplication. For adding, we just, took the derivative of each individual term, and it was fine. It doesn't really work that way for multiplication. For multiplication, if you look, we've got two functions with f of x, and we have g of x. They're being multiplied together. And one way to do it is what we did, and it wasn't too bad, where you actually just FOIL it out and then find the derivative and it's fine. Sometimes this is a little bit of a shortcut or a little bit of a helper, depending on what your problem looks like. You've got two functions, so you have the first function times the derivative of the second function, plus the second function times the derivative of the first function. So you just kind of flip-flop them. So here's what that means. We've got this little guy here, and we have to use the product rule. On a quiz or something, if it says using the product rule, that means you can't FOIL it out and then find the derivative. It means use the product rule, and I will be looking for that. By the way, this isn't on your quiz tomorrow. Tomorrow just covers all of last week's stuff. Okay? So quotient and product stuff is not on there. So here's our first function. Here's our second function. So we say for derivative of y, we say the first function, so we just write it as it is, 4x squared plus 1, times the derivative of the second function, which is what? Just 2, right? Just 2 for that guy right there. Plus the second function, we write him just like he is, times the derivative of the first function, which is going to be what? 8x. Good. And now we need to simplify it, so let's go ahead and distribute and see if we can combine anything. 2 times 4x squared is 8x squared. 1 times 2 is 2. Plus, we're going to have 16x squared minus 24x. We combine what we can. 8x squared and 16x squared is 24x squared minus 24x plus 2. Does anybody have any questions about how to use the product rule? Okay, those are pretty easy to see. I think what's harder for students to see is the next one. What most kids want to do is they want to call that 4x cubed cosine x. You can't do that. This is two different functions you're multiplying together. Here's your first function. Here's your second function. You have to use the product rule or you're going to get the wrong answer. So we say, okay, the derivative of x is first function, which is x to the fourth, times the derivative of the second. What's the derivative of sine of x? Cosine. That's the one you had to have memorized. Cosine of x plus the second function, so sine of x, times the derivative of the first one, which is 4x cubed. What's wrong with the way that we wrote that? Yeah, we probably need some parentheses, or probably the order is really what's wrong with this. Because even if I do say, oh, I'm multiplying those two, it looks like I'm taking sine of that whole thing. And we're not. It's really sine of x times that whole guy there. So we need to flip the order. So we have x to the fourth cosine of x plus 4x cubed sine of x. And that's your answer, written correctly in a way that makes some mathematical sense. Questions on the first two? Okay? All right, quotient rule. You got to have this guy memorized too, and he looks pretty nasty. It's really not that bad. And if you're like a color-coded person, you can kind of take all of your F's of X's there and all of your G's of X's. And rather than memorize F and G and all of that mess, this is what a lot of students do that make it a little bit easier. The derivative of a numerator over a denominator, so top over bottom. Here's what a lot of kids say. It's the bottom times the derivative of the top, so Booker T, don't forget the derivative, minus Taco Bueno, don't forget the derivative, over the bottom squared. Now that's kind of goofy, I mean, but you might remember it. Booker T minus Taco Bueno over B squared. B and T are bottom and top. Just don't forget your derivative piece. So let's try it. So we scooch down. We have a very clear bottom and a very clear top. So we say the derivative of y equals Booker T. So bottom times the derivative of the top. What's the derivative of the top? 2. Good. Minus the top, Taco Bueno, the top, so 2x plus 5, times the derivative of the bottom, which is 3, over the bottom squared. Now, for the multiplication, for the product rule, the order didn't really matter because you're adding them. For the quotient rule, the order certainly does matter because we are subtracting. So just be really careful about that. And now we can simplify it. 3x times 2 is 6x. I'm going to distribute the negative and the 3 at the same time. I hope that doesn't throw you off. So I have negative 6x minus 15 all over 9x squared. 6x minus 6x is nothing, so I have 15 over 9x squared. Don't forget to reduce. Negative, thank you. I did that first hour too. 3 goes into both of those, so we have negative 5 over 3x squared. And there's your derivative. Are there any questions with how the quotient rule works? It's really not bad. Until you get to the back side. All right, next page. Notice I've left quite a bit more of white space for this one. This one can get a little crazy, so we really want to be careful. So let's take it one step at a time. And just so we don't forget, let's write down our quotient rule. We're looking for Booker T minus Taco Bueno over B squared. So here we go. The derivative of f of x is Booker T, bottom, so x cubed plus 1, times the derivative of the top. Now before we find that derivative, what should we probably do to the top? Yeah, let's rewrite this as x to the 1/2. So the derivative of the top is 1/2 x to the negative 1/2. Yay. Minus Taco Bueno. So the top is x to the 1/2 times the derivative of the bottom, which is 3x squared. All over the bottom squared. That's the calculus part. The calculus part really wasn't that bad. The algebra might kill some of us. So the calculus part, not hard, and now the difficult piece comes with the algebra, because this gets pretty messy pretty quickly. You can't just leave it like this. I mean, that's pretty gross. You're going to need to put some things together. So let's go ahead and do what we don't want to do. Let's distribute. So if I've got x cubed times 1/2 x to the negative 1/2, first of all, just deal with the constants, or the coefficients. We've got 1/2 times 1, so I have 1/2. The bases match, and we're multiplying. So what do you do to the exponents? Add them. 3 plus negative 1/2. It's 2 1/2, or 5/2. So I have x to the 5 halves. Whoops, sorry. Then I have 1 times that guy. Well, that's not bad. I can do that. 1/2 times, or 1/2 x to the negative a half. Minus, all right, there's a 1 here we can't see. 3 times 1 is 3. You're multiplying and the bases match, so you can add the exponents, and you get 2.5 for the exponent, so 5 halves. All over, and we're going to leave the bottom the way that it is. It's pretty simple as it is. Foiling that out is not really going to help us at all. Anybody see anything we can do next? Yeah. This little guy right here can be put together with this guy right here because the variable parts match. Those are like terms. So if we've got 1/2 of those guys and -3 of those guys, I really have -2.5 of those guys, right? So I have -5 halves of x to the 5 halves. Rewrite the rest of the problem. Now for some of us at this point, it's really going to be easier to go ahead and put in our radical so you can kind of see what it looks like and what it means. So I'm going to rewrite this thing as -5. Now this is x to the 5 halves. So that means I've got inside over outside, right? What is that simplified? Is the x squared radical x? Because there's 5 x's in there. 1, 2, 3, 4, 5, and I'm looking for pairs. I'm looking for square roots. So here's 1 pair, here's another pair, and there's 1 guy left over. So x squared radical x? Yes? So we've got x squared radical x on the top, and on the bottom I've got a 2. Plus, let's take care of the 1/2. 1 on top, I have a 2 on bottom. This is x to the -1/2. So if you scoot it to the bottom, got x to the 1/2 on the bottom, or radical x. All of that is a numerator over x cubed plus 1. We're getting close. And it's at this point that you probably want to quit, but please don't. On a multiple choice test, or if you're checking your answers in the back of the textbook, or on an AP test next year, they're looking to see if you know how to do these common denominators. They're going to force you to do it. You're going to have to if you want credit. So let's get common denominators on the top. I've got a 2 and I've got a 2 radical x. It seems like that numerator is going to be 2 radical x. This guy was just 2. He became 2 radical x. What do I need? Radical x. And watch what happens. Multiplying the top. Whoop, that's not a 3. That's an x. Just kidding. Sorry. Got -5x squared. What's radical x times radical x? X. So I really have -5x cubed. Plus, what's my new numerator on the right? It's just 1, because the denominator's already matched. So then the bottom stays the same. And it's really over a 1. So you really have a fraction divided by fraction. When dividing fractions, don't ask why. Flip the second one over and multiply. We're getting close. Last step. Across the top, when you multiply, we're just multiplying by 1, so it's -5x cubed plus 1. Over, on the bottom, it's just multiplying, so we've got 2 radical x times x cubed plus 1 squared. And it really isn't going to get much more simple than that. I mean, you can rationalize that, but I'm not going to make you. Now, let me make sure you understand. You may get this far in the back of the book, still may not exactly look like yours, because maybe they did rationalize that radical x. I'm fine if this is your answer. I will take it and give you full credit. That is not a problem. You worked through the roughest parts. You combined you got your common denominators and shoved them together. You did what you could. That's fine. Please know that, Logan, your answer may not match Bree's, and that doesn't mean you're both wrong. It just means you approached it differently, and maybe you simplified down to a different sort of combination. Does that make sense? So when you're checking your answers with your neighbors, not cheating, but when you're checking your answers with your neighbors, don't go in and change your answer, number one, because that is cheating. And number two, because yours may not be wrong. All right, trust yourself, trust your algebra skills. You guys are smarties, that's why you're in here. Okay? Questions on this? They're not all this gross, but I wanted you to see that. It does happen. Yes, sir?
What grade should we have learned how to do that?
Like common denominators?
Just algebra in general.
Well, it got kind of progressively harder. Like some of the basic concepts came out of 6th and 7th grade math, but then Algebra 1 kind of put some of the exponent stuff together. Algebra 2 dealt with all of the radicals with it. They just kind of kept building. Yep. All right, let's scooch on. Notice this one has much less white space. That's good news for you. Here we go. Are we going to use the product rule or the quotient rule? Quotient. What do we start out with on the quotient rule? Booker T. Cameron set up. So, the bottom times the derivative of the top. And what is the derivative of cosine of x? Negative sine of x. Minus Taco Bueno. Or Taco... Oh my goodness. How many of you are Bueno fans? Bell? Some of you guys don't care. Shame on you. It matters. Food matters. Here we go. The first, or this Taco Bell top. So cosine of x times the derivative of the bottom, which is 2x. Notice I went ahead and flipped that order because I knew I was going to have to anyway. You can do that, and that's fine. All over the bottom squared. All right. Is there anything else we can do to this? What can we do? Yes, I heard it. Let's take an x out of everybody. So this is now x cubed. That x goes away. And this x is now just regular old x. That square is gone. Whatever you do one part, you have to do to all of the parts. And if you can do something to all of the parts, you have to. So we have negative x sine of x minus 2 cosine of x all over x cubed. Now you're done. Yeah, not bad. Next one, derivative of secant of x. We don't have that memorized. We don't even know what that is yet because it's the first time you've seen this. How are we going to get it? Yeah, let's turn this into 1 over cosine of x. Which means we're going to use what rule? Quotient rule. All right, I'm going to keep talking out loud. You try to buzz past me and see if you can finish it out before I get there. So Booker T, bottom times the derivative of the top. So the bottom, the derivative of the top is 0, minus the top, so 1, times the derivative of the bottom, which is negative sine of x, all over the bottom squared. So the derivative is sine of x over cosine squared x. Now this answer is perfectly fine. I would give you full credit on a quiz if that were a question. However, the back of your book and most professors are going to have you change this. They're going to have you break it apart into sine over cosine times 1 over sine. Sine over cosine is tangent, and 1 over cosine is secant. So in the back of your book, it's going to look like that. Next one, derivative of tangent. How can you rewrite tangent? Sine over cosine. All right, see if you can beat me to the punch. Are you finished? Like, are we done? How come? That is an identity. This is what, like, the main one you had to know. That guy right there equals 1. So if we have 1 over cosine squared x, what is that really? Yep, secant squared x. There you go. Now these are handy ones to have memorized. You don't have to have them memorized. All you have to have memorized is the sine and cosine, and they'll get you there. But on an assignment or a quiz or an assessment, if you had those memorized, I would totally take it because, next page, here are the main trig functions. Again, the cosine and sine, those guys, you just have to know those cold. Because if you try to derive them on your own, you have to know the sum and difference identities. And most of you probably don't have those memorized. These other guys, you could derive those. However, you can see some patterns. I would strongly suggest memorizing them. Tangent is secant squared x. Cotangent is negative cosecant squared x. Secant is secant tangent. Cosecant is negative cosecant cotangent. Those are not hard to memorize. You can totally do that. I would strongly suggest that. Again, this is not going to be on your quiz tomorrow, but you do have a test next Monday, Tuesday, something like that. I'll make sure you're ready for it, and I would have those memorized. All right, let's find the next one here. We've got derivative of x cubed tan x. Are you going to use some kind of product or quotient rule, or can we just dig right in? Product rule, you have to. We have 2 functions here. So we have the derivative of f of x is the first function times the derivative of the second one. Well, you've got a little cheat sheet in front of you. Tangent is secant squared x. So secant squared x plus the second function times the derivative of the first. So 3x squared. And that's all you can do with it. Nothing fancy. That's it. Does everybody know how we got there? Okay. Let's see the next one. Are we going to use a product rule or quotient rule, or just jump right in? Yeah, just jump in. This is not a big deal. We can do this. So we have negative of whatever the derivative of cosecant is, and according to your paper, it's negative cosecant x cotangent x minus the derivative of sine of x, which is cosine of x. So that negative became a positive. You can see that. So that is your answer, and we are good. Almost done. Next one. Find the derivative of that thing if c is a constant. You're going to use quotient rule because we're dividing some stuff. Booker T minus Taco Bueno. So the bottom times the derivative of the top. Now the first term is easy. That's 2x. How about this second term? Isn't c a constant? Just a number? What's the derivative of a number? 0. So we just leave it as 2x. Minus Taco Bueno. So top times the derivative of the bottom, which is just 2x, because the derivative of the constant is 0. All over the bottom squared. Let's distribute and see if we can get rid of a couple things or combine some stuff. We've got 2x cubed minus 2xc squared minus 2x cubed minus 2xc squared. All over x squared minus c squared, the quantity squared. All I did was distribute. I've got 2x cubed and a negative 2x cubed, so those can go away. Then I'm left with negative 4xc squared. Say what? You okay? Try and slow down. Okay. So I combine like terms, and then the bottom, it's totally fine to just leave it like that. Chances are with derivatives, you're trying to get it to a different answer anyway, so you're just going to end up plugging stuff in. And that's it. Questions?
How do you know when you're done? Does that make any sense? Like,
You
that's
squish it as much as you can.
That's it. I don't know how to tell when it's complete.
You squish it as much as you can. I mean, because you figure if you had foiled this out, Nick, it wouldn't help you. You wouldn't get anywhere. It would just look grosser. More gross? Grosser? I don't know. I don't teach English. I'm not my husband. Yeah, if you can't take anything else out, you can't squish anything together and shove it together, then you're done. Yeah, super technical. The last guy. You're multiplying 3 things. Write this off to the side. You've got, I'm just going to, for room's sake, I'm just going to call them F, G, and H. So you're multiplying these 3 together and you're trying to get the derivative. You're going to do the derivative of the first one times G times H plus F times the derivative of G times H plus F times G times the derivative of H. In other words, they all get their own turn. They all get their own turn at being a derivative. Does that make sense? You're just adding them? Don't like it, but not too hard. It's really not bad. Everybody got that much copied down? Okay, here we go. Bless you. Derivative of f of x. So, derivative of the first guy is what? 6x squared plus 5. And then times just the last 2 guys the way that they are. So x minus 3 and x plus 2. Plus. Alright, the first guy, he's already had his turn as a derivative. So we're going to write him like normal. Times derivative of the second guy is what? 1 times the last guy just as he is. Plus. First and second guy, they've both had their chance at being a derivative, so they're just normal now. Times the derivative of the last guy, which is 1, right? Now here's the thing. You've written all that out. That is a whole lot of foiling and distributing and shoving together, and then, yeah, kind of crazy. Sometimes it is faster to just do all your division up front, or your multiplication up front, and then find your derivative. And that's the case with this one. So, my point is to show you, you've got choices. Here's your second option. Derivative of f of x is, let's leave the first guy alone. And these last 2, we can foil those super fast. That's not hard. We can do the last 2. We can foil that. First, outside, inside, last. You're going to get x squared. The outer and inner terms combine to negative x, and then minus 6.
Wait, can you explain that again?
Yep. Your outer terms and your inner terms combine, and you get negative x in the middle. So we foiled. First, outside, inside, last of these last 2 guys. How does that make sense?
Yeah.
Okay. All right. I'm going to take all 3 of these times 2x cubed. So I've got 6x to the 5th, not 6th. Next guy is negative 2x to the 4th.
Actually, 6.
I don't know what I'm doing. I think I did the derivative or something weird. How about a 2? Sorry, good catch. Huh. 2x to the 5th. Good one. And then times negative 6 is negative 12x cubed. Then we take everybody times 5x. So I have 5x cubed minus 5x squared minus 30x. These 2 guys in the middle we can combine to negative 7x cubed. Rewrite the rest of the problem. Yep. I don't even know I put derivative there because that's not even what that is. Now we're on derivative. Whoops, sorry. Now find the derivative, and that's the easy part. The calculus is not the hard part. So we have 10x to the 4th minus 8x cubed minus 21x squared minus 10x minus 30. Say again? Yeah. You mean, can you just do it this way? Yeah. From here to here?
Yes.
Derivative. So 5 to power rule. Okay? Your assignment's on here. Let me tell you guys though, tomorrow what happens?
Well, you